Hey everyone, today I'm going to show you how to do proofs in maths really easily with this special strategy, my last result method, right? Now warning, you're guaranteed to get 100% in these questions, but make sure you stick to the end to watch out how to do this method properly, right? And why there's precautions, okay? So let's get into what this method is. Alright, so what's this last result method? Well, it's called doing it in reverse, so that's what name I give it. Right. So it works for questions where you have to prove in maths, algebra, trigonometry, where you have to prove left-hand side equals right-hand side. So you've got to prove it, show it, or even for inequalities, right? You've got to prove an inequality, greater than, less than, doesn't matter, any variation. So what the method is we're going to assume the actual answer is true and manipulate that answer and work backwards until we get something that we know is 100% true, right? And then here's the kicker, so what you're gonna do is then you basically rewrite that in the reverse order, and that's how you do the question, right? But warning, this method is probably illegal because you don't like, your teacher won't like you assuming the answer is true. So this is why I call it a last resort method, because I teach this to my students because if they're stuck in the exam and they're stressing and they need to get those marks, then this is their last resort. It's guaranteed to get for most proof questions. It doesn't work for all proof questions, but works for most of them. And doing it in reverse shows you basically how you would do the question, or one way to do the question normally, right? So what we're going to do is use scrap paper, right? Use scrap paper to do it in reverse, and then in your exam, you're going to write it how you should do it properly, right? So let's look at two examples, one with an inequality, one with a trigonometry proof of how to apply this last result method. Okay, first example. If x and y are both greater than 0, prove 1 on x plus 1 on y is greater than or equal to 4 over x plus y. Alright, so you're in an exam, you're rushing your time, you're stressed. You look at this question, you've got no idea where to start really. Okay, so what we're going to do, we're going to get your scrap paper. So I recommend you ask in an example extra scrap paper to do extra working on, which you do not give, you throw it away so they don't see you doing this, right? This is a last resort method, okay? So what we're going to do is we're going to assume the answer is true, right? So we're going to start like this, and then we're going to start manipulating that answer. So first up, I can add these fractions. So I'll get x plus y over x, y greater than or equal to 4 over xy, right? So if you're not sure how to do that quickly, I'll leave a link to my adding fractions instantly, just by cross multiplying. So now here, we're going to do the same thing. We're going to cross multiply to get rid of these fractions, but you'll notice this is the same thing. So this becomes x plus y squared greater than or equal to 4xy. I've got a perfect square, I can expand that, so that's x squared plus double their product plus y squared greater than or equal to 4xy. I've got like terms, so I can bring this over and I get x squared minus 2xy plus y squared greater than or equal to 0. And lastly, you'll notice this is exactly that, but with a minus. So this is also a perfect square, but with the minus. Now look at that, we're done. Why? Because this is 100% true. X and y are positive numbers, and if we subtract them and then square it, obviously it has to be at least 0, right? When you square a real number, it has to be at least 0. So this is 100% true. So this is what you do on your scrap paper, but in the exam, you're going to rewrite it. So you'll say, we know x minus y squared greater than or equal to 0, right? That's 100% true. So then we just expand the brackets. Pretty much, we're actually just writing this in reverse. We add 4xy to both sides to get this. This is now another perfect square we can factorize. And then we divide this side by x plus y and this by xy. Oops, that looks messy. And you get 4 on x. And then to go from here to here, we split the fractions, right? Because this is adding. If we split it, we get x over xy and y over x, y, and the x will cancel to give you that, the y will cancel to give you that. And look at that, we're done, we've proved it. Without having any idea how to do it and just working backwards, we've proved it. So if you write this in an exam, even though this is probably not the intended way to do it, it's one way to do it, you've done nothing illegal. So if your teacher just sees this, you've done nothing illegal. You've started from something we know is 100% true, so you're going to get 100% of the marks. So you've got to be very careful that you don't, or another strategy is, if you don't have scrap paper, is to leave room and actually write here. So start here and then actually write upwards, which I'll show you in the next example. Right? Okay, so let's look at this trig proof example. Prove cos alpha over 1 plus sin alpha equals sec alpha brackets 1 minus sin alpha. Now last week on Wednesday I did do a video on how to do trig proofs with my special manipulation list, so I'm going to leave a link here so you can check out how to do this properly. Not illegal and really great strategy, but here, let's say you got no idea, let's apply this method, last resort method. So as I said before, if you don't have scrap paper, another way to do this is leave space here and start from the end, right? So let's just say therefore cos alpha on, let's assume we've already proved it. And just go up backwards, assuming it's true. So assuming this is true, what would I do next? Well, I'd get rid of the fraction, times it over, because I notice I've got 1 minus sine, 1 plus sine. 1 plus sine alpha, 1 minus. And then this is a difference of 2 squares. So that's 1 minus sine squared alpha. So all I've got to know here is one basic identity. But cos squared plus sine squared equals 1. So all I've got to know is this. Cos squared alpha plus sine squared alpha equals 1. Because then that means this is cos squared alpha. So this is cos squared alpha. And now all we need to know is that sec alpha equals 1 on cos alpha. So 1 on cos alpha cancels with that. And look at what we end up with. Cos alpha equals cos alpha. Now you wrote this in the exam, your teacher is going to look at you like you're the weirdest person ever, but this is 100% correct. Right? Because look at this, cos alpha equals cos alpha obviously, and all I'm doing is just rewriting it as sec alpha cos squared alpha using this identity. Then I know cos squared alpha is 1 minus sine squared alpha. Then I factorize as a difference of 2 squares, and then divide it over and I prove this result, doing it in reverse, right? So you can see how powerful this method is if done correctly. If you write an exam like this, you look mad, but you're still right. You haven't done anything illegal, and you're right. You'll get the marks. Okay. So hope you enjoyed this video. So make sure to give a thumbs up, like, comment, and subscribe to get future awesome tricks like this.